So, hello everyone, welcome back to the today's video of day 143. So, let us start the today's question and so that we can learn, grow, maintain a streak together. So, today's question name is maximum possible value. The tags are mathematical and algorithms. So, let's read the question that they're given two arrays A and B of the same length. So, there are n type of sticks of length specified. Each stick of length is given in A of I, and the number of units of the particular length of stick is represented in B of I. Okay, we have to construct the squares and rectangles using these sticks. Each unit of the stick can be used as length or breadth of the rectangle as the side of the square. Okay, so to build a length or breadth you have to use the stick. A single unit of stick can be used only once. Okay, each kind of stick has a different length. Okay, let us read the input and output. Let us understand how the input and output are coming, and then we will proceed ahead with the solution. So the eighth array is representing 3, 4, 6, and 5, and the bth is 2, 3, 1, 6. So it says that there are two sticks of length 3. Okay, as we read in the question, b is representing the number of sticks and a is representing the length of a stick. So for the first entry, if you see, it's saying there are two sticks present of length 3. There are three sticks present of length 4, and similarly so on, right? And they are considering one square can be made using the four sticks of the fourth kind. Okay, so they are using this four sticks of length 5, and they are building a square, and they are calculating the parameter, I guess. Yeah. Okay. So the task is to calculate the maximum possible. S is the sum of the lengths. Okay, so they need to find the parameter. Okay, similarly, now they are considering a rectangle which can be using two sticks of four. Okay. So let us get back to the paint section, and how they are doing is that they are using let's write this. It is 3, 4, 6, and 5, and the numbers of the length of the sticks are present as 2, 3, 1, and 6. So what they are doing is that they are taking 4 sticks from here, that means the remaining is 2, and they are building a square of length 5 using the number of 4 sticks. So you can see the parameter is this is a square, so the parameter will be nothing but 5 star 4, that is 20, right? Now if you look at it, then you still have this length 2 remain, right? So they are using these two sticks as well. So that means then you will have the zero number of sticks remaining of length 5, and they are, let's say they are making these two sticks, because to make a rectangle or square, the square has the all the sides equal, whereas if you want to build a rectangle, then the opposite side should be equal, right? Now I need two pair of sticks with the same length, right? So let us go back to the question and see if there are sticks remaining. So 6 has only one unit length, so I cannot take this. Now 4 has 3, whereas I can take 2, right? So if I take 2 length, then it will be x will be equals to 4. X will be equals to 4, and if you find the parameter, then it will be 5 plus 5 10, and 10 plus 10 plus 8, that is 18. But there was another possibility as well for the same thing. When I did this thing, that 5 and 5, right? So I need just two pair of sticks which have the same length. So can I get any? Can I get any? So let's say this length is again x, right? So is there any availability? Yes, there is a length. There is a stick of length 3 which has 2. So let's say if I have taken this, then the remaining will be 0, and you can see that x equals to 2 I can place here, right? And then the length would have been 14, right? But this we can build, and after that either I can build this or either I can build this, right? And the constraint is saying that to take the maximum possible, right? So I will reject this condition, and I'll take these two, that is 20 plus 18, that is 38, and that is what given in the question, given in the output, right? So we have an understanding now. So I think the exact thing that I showed you in the dry run, I think that would be a brute force technique, right? That first you need to sort the a of I, right, according to the length, and then you need to see that take the highest length possible, take the pair from there, and if there is something remaining, remaining number of sticks are if there are remaining some number of sticks for the maximum length, then try to do it for the just second largest length of the stick, right? But this will be, I guess, a more complex technique. You have to maintain several things. You have to iterate. First you have to sort, that will itself take n log n, and then you have to maintain the pointer for the largest. You have to check that if there is some remaining sticks or not, then you have to again check for the second largest length. it would be a complex approach, I say, right? Rather, if there could exist a technique in just one iteration, we would have maintained everything. Can we do something like that? So let us visualize this thing again. Let us write the test cases again. So we have the test cases as 3, 4, 6, and 5, and the length as 2, 3, 1, and 6, right? One thing I can say is that let us start from the basics. That suppose this is a square which has the length have sides equal, and suppose this is a rectangle which has the length, right, and which has the breadth, right? So I can say that the parameter of this thing will be nothing but force cross L, or I can just say it will be L plus L plus L plus L, and I can say for this thing as L plus B, right? Similarly, here in this case, L is equals to B, right? So it is as good to say that I can replace this L with B. I can do that. Then if I find the parameter, then I will say again that it equals to L plus B, because every square is a rectangle but not a vice versa. Because rectangle, there is one just condition that the opposite side should be equal, right? So for each and every rectangle, for each and every we are forming this quadrilateral, let's say. So let's form a rectangle for each and every case, and we will use this formula, either it be a square, either it be a rectangle. So if we are clinging to this formula, then I can say, we need to pick sticks in pairs, right? If I just write it for you, need to pick these sticks in pairs, because I need 2L and I need 2B. So that means I need to pick two sticks which have the same length, and then I need to pick the another two sticks which have the same length as breadth, right? So here goes our first condition that I need to do in my logic. And since we are using we are picking the sticks in pairs, that means that the pairs should be in even, right? So, if it is in pair, then it should be present in even number, right? Also, that means that if there is an odd number in a in number of sticks, this is the number of sticks, right? So if there is an odd number, I need to reduce it down to an even number, right? So that means I have to make it minus minus. So 3 goes to 2 and 1 goes to 0, I guess, right? And you can see we have not used this length stick in our above solution, right? So, okay, so according to this intuition we have here, we need to do first step is that convert all the number of sticks into even length, maximum possible even sticks, right? Once we did that, what we need to do is that let us find the parameter. So, so we need to pick the even number of sticks, like, so it is even now, it is 2, and let's pick it. So if I pick the stick, so let's say you have it as total sticks, and then let's name a variable as total parameter. So total sticks here with if I calculate the parameter for this I, it will be 3 cross 2 6, and then 4 cross 2, that is 8. It is 0, 6 cross 0, so there will be nothing, and 5 cross 6, that is 30. If you sum it, it will be 38 plus 6, it will be 44, right? And how much and how what is the number of sticks that we have used in getting this parameter as 44? We have used all the even number of sticks present, right? So I can say we have used 2 from the I equals to 0, 2 from I equals to 1, and since in the third there was nothing, so for the fourth I equals to 3, I have used 6, so it will be 10, right? But you can clearly see that forming a rectangle, I just need 4 sticks, right? 4 sticks. So I have used total sticks of 10, right? So that means if I do 10 by 4, I'll be getting how many rectangles are formed, and I can clearly see that 2 rectangles can be formed from here. 2 rectangles plus 2 extra sticks are there, right? I need to I need to subtract these extra 2 sticks from my current answer, right? And since the constraint is saying that you have to make the maximum possible answer, so what should be the constraint on these 2 extra sticks? That is that while we were iterating, we have to maintain the minimum stick length as well. That among all the sticks, which stick has the minimum stick length, and then we will subtract it. Then only we can clearly say that the number of rectangles formed are actually having the all 4 sticks in each and every rectangle, and there is no extra sticks, right? So that means there will be one more variable, let's say minimum length variable, While iterating, we will maintain this thing as well. So for I equals to 0, our minimum will be 3. Then it is compared with 3 and 4. Then again it will update to 3. Third iteration we are not taking because it is 0. So either if you take it also, the minimum will be updated to 3, right? Yeah, it will be updated to 3, as well as for the fourth iteration it will again update to 3. So that means you need to subtract 2 extra stick length, so it will be 2 in 44 into 2 minus 3, that will be 38, and this was our answer, right? So I hope you are able to get the intuition here, right? And one more thing, that while you were comparing the minimum length, so suppose in this case we encountered that it is 0, right? And I do not need to consider it, right? So that means while comparing the minimum length, I will just say that this thing was representing b of I, right? The number of sticks. I will say if my number of sticks is greater than equals to 2, because that was the condition, then only I was picking it, right? I was picking it for my total perimeter, yes. So if it is greater than 2, then only do the minimum process. So I have given you the dry run, all the variables and how the things are going. So let us pause the video here for maybe 5 to 10 minutes and try to code this approach yourself. And since we are just iterating once in our in this array, so the overall time complexity will be O of n and the space complexity will be O of 1, right? Let us see what the constraint says and then we will proceed ahead. So n is 10 power 6, so definitely it is 10 power 6 is definitely less than 10 power 8, right? So if we are able to code this approach, which is we will be, and this approach is right, so it will successfully get submitted. Okay, so let us open the code editor now and start coding. So we were to iterate in a for loop. So for int I equals to 0, I guess this code is very obvious, right? So I will mention some of the skeletons and then I will explain you how the code is working, right? So since this code is very simple and I don't think it requires the live coding here, so I have written this code in my code editor and then I'll explain you how the things are going. So what we discussed in the paint section was that we need to do only three things. Calculate the total. First, you need to decrement if there is an odd integer decremented by 1, so that we can make it the maximum possible even array. So that's what we have done. When I am iterating, I'm just seeing that if that is an odd integer, I'm doing minus minus, right? The second thing was, the last three things were that I need to maintain a minimum length, I need to maintain how many sticks I used, and I need to maintain total perimeter, right? You can see here. And minimum length criteria was that if it was greater than equals to 2, then only I was including it in my perimeter. So that will be the same condition. So to consider the minimum length of the sticks, right? So this is nothing but that I am maintaining the minimum length, right? And to store the minimum length, so earlier I was showing you the C++ code I have written. So let us switch back to Java. So okay, so the same conditions are here. If it is odd, then I do the minus minus just once to make it even. Then I'm comparing the minimum length. Then I'm maintaining the total sticks. How we can maintain the total sticks? That you just have to make maintain the total sum of your bi, right? So that's what it is done here. We are maintaining the total summation of the bi array every and each time we are iterating. Similarly for the total parameters, so the number of sticks used into the length of each stick will be give you the total let's say perimeter, right? And at last we are saying that if the total number of sticks is used is not divisible by 4, that means that the extra sticks need to be minus from my total perimeter answer, right? And since we want the maximum possible value, that is why we were using the minimum length of the stick and we are subtracting it. And also if there is any even number that is not divisible by 4, then always the remainder is 2, right? You can verify it for each and every number. So and at last we have returned the total parameter. Let us compile and run, and then we will hit the submit button. So great, the expected output and output matches, and since the code is written in O of n, that is 10 past 6, so it will definitely get submitted. Let us verify that as well. So great, our code got submitted, and I hope you were able to maintain your streak of day 143. So great guys, let us meet in the tomorrow's streak, and Before that, that's in the left right hand side, you can see the Java code which I just explained you, and on contrast to that, in the left hand side, the C++ code for the C++ users as well. So let us meet in the tomorrow's video of day 144. For till then, bye bye, take care, keep learning, keep growing.